Alright, welcome back. This is Mr. D with the Please Physics tutorials. We're going to go over number 24. Number 24 says, Harold throws a ball 10 meters per second at 33 degrees. How far does the ball travel horizontally if it is in the air for 1 second? Alright, let's use GFFS for this. What is given? So if we look at it, it says the ball is thrown at 10 meters per second at 33 degrees. So the velocity, what we start off with, we'll call it an initial right now. And we're going to call that 10 meters per second. Now, the angle that we threw it at was 33 degrees. I always want to come off of the positive x-axis, so we always go counterclockwise. So we know this is 33 degrees north of east. Alright, what else do we know? Okay, so we know that we have a vector right now. It has magnitude and it has direction. And we want to know how far the ball travels horizontally if it was in the air for 1 second. So, we were given time. So, the time is 1 second. So, we want to find how far it goes. So let's do the find section from our GFFS. Alright, so put down displacement in the x direction. That's what we're looking for. Now, the formula you're going to use is the formula that you use to find components of a vector. So let's quickly do a little sketch before we write down the formula. Alright, so about 33 degrees is right there. So 33 degrees, and the magnitude is going to be 10 meters per second. And we look at that, and that is not only going to the right along the x-axis, it's also going up along the y-axis. So what we need to find out here is we want to know how fast it is going along the x-axis, because we want to find the x displacement. So, in order to do this, we can divide this into components. It's moving up and it's moving to the right. So now, let's find out this component. So we'll say the x component of this vector. Alright, so the x component, then you have to say to yourself, what is the formula I'm going to use to find the x component? Alright, and let's just draw in the y component for reference. Okay, so this is the y component. And we're going to relabel this just to make the formula make sense. So most of you understand that I've said in the past, if the angle comes off the x-axis, always use cosine. So let's prove that. So let's go to your memorized SOHCAHTOA. So, ka, to, a. Alright, so you have to make a determination. What do I want to find? Which formula is right for this? Alright, so let's look at the right triangle. Here's the right triangle now. Here's the angle, so this has to be the opposite. It's opposite to the angle. This is right next to it, adjacent. So we're going to call this adjacent. Okay? Then you look at the formulas and you want to find something with adjacent in it. Alright, so has opposite over hypotenuse, won't work. Alright, then both of these have adjacent. All right, but this one is the one we want to use. We'll use tangent a little later in other videos to find angle. So we're going to use the cosine angle. So let's put it here and then I'll transfer it into our formula section. Is adjacent over hypotenuse. Okay? Now, we could substitute for adjacent x component. Okay, so let's erase that. So we're going to say x. So I want to find x by itself, the x component. I want to know what that velocity is in the x direction. Alright, so I got to get rid of hypotenuse. So multiply both sides by hypotenuse. It cancels out on one side. So now we have the equation we're going to use. So let's put this in the formula section. Alright, so it's going to be the hypotenuse times cosine angle equals x. So that will tell us what the velocity is going to be in the x direction. So when we look at this, I didn't talk about any wind, air resistance that's going to cause deceleration, and when you throw this, it's not going to accelerate once it leaves your hand. So what we can say is the direction in the x is going to be the velocity in the x direction, and it's the same for this entire path. And so what we're going to do is say this could be average velocity, because it's constant velocity, which is going to turn out to be average velocity. So figure it out right now. Alright, so what you should have done is hypotenuse is 10 meters per second, plug it in there, and then take the cosine of the angle 33 degrees. When you do that, the answer will become 8.39 meters per second. Now, what we wanted to find was displacement, so we're not done. So you have to find out what is the formula for displacement. Now, you look at what you know right now. Okay, so we're going to put the line up here because this is average velocity. So, what formula do you know for average velocity? So, average velocity is displacement over time. So, displacement over time. Sorry, that's a t. That should be an x. Now, I want to find displacement. So I'm going to rearrange this formula. I want to get rid of the t. So I'm going to multiply both sides by t. The t's will cancel out, so now our formula is displacement is the time times the average velocity. So let's come over here and plug that in. So displacement is the time, which was given, 1 second, times the average velocity, which we just calculated, so this is easy math. 1 times anything is going to be the same thing. So it's going to come out to be 8.39. Now, look at this. You have seconds in the numerator, and you have seconds in the denominator, so they cancel out. So your answer has to be meters. So don't get sloppy. Don't just put numbers down, because you're going to miss the units. And if their unit is wrong, the answer is going to be wrong. So that is our answer for displacement. Now you have to say to yourself, sig figs. How many sig figs should it be in? Since the initial velocity is 10 without a decimal, I keep doing this, alright, it has 1 sig fig. So when you multiply or divide, you look at the least number of sig figs and then one of the numbers you're using in your multiplication or division. So we're going to have to go to 1 sig fig here. So you look at this, it's going to be that sig fig. Look to the right. Is that 5 or greater? No. So it's just going to be 8. So we'll say approximately 8 meters, circle your answer, and you're done. So a ball thrown at 33 degrees at 10 meters per second will have a horizontal displacement in 1 second of 8 meters. Alright, hopefully you got that. Just don't sit there, do this as I'm doing it. Let's go to the next video.